watering. And so you consider that for all your applications. Please do that, application by application. I don't want to give you something that you take from here and think that you can apply it without doing some further work and research on it, because that's what you really have to do. Okay.
When we use more polymer, that is difficult to dewater.
It can be, depending on the poly and your material that you use.
I know. Yes.
And you don't, I mean, poly is very expensive as well.
Yes.
So again, do you want to use 10 dosage of poly to get 1 NTU, whereas maybe you're going to get 1.5 NTU with 7 dosage.
Yes.
So it saves you a whole lot of money for half an NTU. What or dewaterability? We just talked dewaterability now. So to get 20% dry solids, you're using 10. But to get 18%, or let's use a better figure, 30. Use 10 for 30. We're using 15 to get to 45%. What's cheaper now?
Yes.
The cost for that increase in poly relative to the water that you take out, which saves on your volume that you need to transport.
We are 60 to 70% solids.
But what is the cost for your disposal? So you need to start
Yes.
looking at that. Like
Yes.
I was saying, it's a logistics game, sludge disposal management. You're driving around sludge.
Yes.
And so you don't want to drive around water unnecessarily. But if 30% dry solids at a certain cost of poly dosage and cost for transportation is your cheapest option, then you obviously go for that. But if you have a higher poly dosage and it comes out cheaper, then you obviously go for it. But look at the entire life cycle is what I'm trying to say, I guess.
Okay.
I don't know what your cost is, and if there's a cost for disposal if you're taking it to a landfill site. The gate fee is what you need to start considering. We often come across areas where people haven't considered that. And then it's very difficult to try and sit and talk to the guys and say, well, what is your disposal cost? We're driving it away. Yes, you're driving away. So what are you paying? X per ton or whatever. Okay, that's the transportation cost. What about the disposal cost? Or the offloading and handling, storage, whatever, if you're taking it wherever you go.
Yes.
Oh no, we do that. No, but that's still a cost. Is that cost built in? So this is all about choices, I suppose, what we say in here. And remember, typically, the cleaner your raw water source, the less chemical you're going to use and the less sludge you'll produce. So if you've got a choice between that, you need to consider that life cycle analysis. The choice of chemicals becomes important to contemplate as well. So your jar testing will tell you a story if you're using alum, lime, ferric chloride, any poly. Lime produces more sludge than ferric chloride, which in turn produces more than alum. So there's your starting point. Polymers produce the least amount of sludge, and if used as a coagulant aid, may reduce the quantity of residue. So people jump on the bandwagon, of course, salesmen, and they say, oh, you must use a pre-flock and a coagulant aid and blah, 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 blah.
There we use lime as a primary coagulant.
Yes. Where?
There.
You can use it on many applications. So depending on your raw water or your water that you need to treat, you can apply it. So you must give me your water quality. I can't tell you because there could be something in there that's not going to affect the quality of that. But in typical conventional water treatment, you can use it.
It is mainly used to maintain the pH to the level that the next reaction should occur.
No, but that's not, so don't get confused between pH control,
Right.
flocculation, and what we call stabilization. I'm getting into water treatment now, guys. And I'm reluctant to go down here because we haven't got time to talk about this. So you must come back for the water treatment course. But remember, your flocculant, if we go back to that, I don't know how to change it on you. That slide that showed you flocculate, add pH at the inlet, that pH, and then you add pH at the end as well. Here's our water treatment processes, as many as we need, depending on. So that will determine, this quality will determine that, plus this quality. So what is the quality of this? What is the quality of that? Then you can select this. And that could mean just one block. It could mean a whole lot of different blocks. And then you start optimizing by saying, okay, so if this is sedimentation, this is filtration, and let's call this disinfection, just to be standard. So this is flocculation. What chemical are we adding there?
Aluminium and
Do your jar test.
aluminium and polymer.
Do we need to add both? It'll depend on this, it'll depend on that. Yeah. It's going to depend on cost for that.
Yes.
It's going to depend on cost for that. So you've seen how it all connects. Your water's got a certain pH.
Yes.
You need to know what that is. It depends. I can't tell you what it is. Your flock has got a certain pH and a certain pH that it operates in. So that and that have got to be the same. If they're not the same, you must add pH correction.
Yes.
That pH correction is only making sure that this water and this chemical are at the right conditions to be able to work properly together.
Okay.
There's another thing that we call stabilization. What's stabilization? What's the difference between stabilization and pH correction?
pH correction is we have to got it in a required range, in specific range. We add acid or caustic to maintain pH at a certain level, like 6 to 7, 7 to 8. And
but what are you? So why? What's your overriding factor that's regulating why your pH must be between 7 and 8?
So that the next chemical that we are using for flocculation, it should react properly to make the flocks. For that purpose, we are preparing it.
So what is that? Is that stabilization or pH correction?
no,
That is pH correction.
Yes. That's pH correction. So what is stabilization? Stabilization, your water is either hard or soft. So this is the physical characteristic of this water, the aggressiveness of the water. It's either scale forming or it's corrosive. It's going to eat away at your pipes and your fittings or deposits scale. And then you put it into a hot water system and you get more scale, because the hotter the water, the more the scale precipitates. And so you should do stabilization of your water as well. And you can do that anywhere, but it's not the same as this. This is pH correction. You're not stabilizing your water here. That's just purely that pH and that pH. You've got to make them the same, or in the same range. Otherwise, that's not going to work. Then you're going to be putting more chemical And you still might not be getting the right flocculation here, and therefore the right sedimentation. We don't really go into this in this, but we do it in water treatment. Stay Soft was the program that we gave you guys last time to look at how you can stabilize your water. So things like the Reisner index, Langlia saturation index, if you're familiar with that.
Yes.
Those are for stabilization of the
After
water.
pH correction, water becomes stable. Like certain, if pH goes a certain level, water properties become scaling.
Yes.
If pH goes below certain level, water become crucible.
Well, it's not the pH, it's the salt concentration here.
pH is the
Should,
combination of the salt
Yes.
concentration.
That's
So
foam.
you got to, that's why I'm saying you've got to look at the concentration of that water coming in, not just the pH.
I indicate the
Basically,
problem in the
it's a
biological
combination of
foam.
three elements: salt concentration, pH, and temperature.
Correct. We'll touch on that just now. Are we okay with that? Well, I don't want to get stuck on that right now. So people, we tend to, in practice, talk about pH correction as either stabilization or pH correction for that. Just make sure that you're talking about it in the right application, because the next guy that comes in, that's a graduate, he hears you talking about pH correction and he thinks it's that, or he thinks it's stabilization.
Tomorrow, maybe you we discuss the foam in the biological tanks. Maybe tomorrow you discuss why the foam, more foam produced
Yes,
in the.
yes, we'll talk foaming tomorrow.
Okay.
Okay, because you'll have lots of foam.
Yeah, lots of foam.
And because you're killing your bacteria, that's why.
Yes, yes.
But we don't like that.
No, so yeah. And
We are facing this
we'll
problem.
talk biological tomorrow.
Okay.
So, recovery of chemicals. You will find that it becomes, technology is developing, right? In the 60s, we looked at reverse osmosis in South Africa and we went, oh no, this is too expensive. And we packed it away. Because membranes weren't lasting, membranes were expensive. We didn't realize that pre-treatment of the water is very important. And so technology develops to a point where it becomes really affordable. And we're going to find that with the recovery of chemicals. We're going to find that as the world demands that we start applying circular economy to all these things, and as people respond by developing technology that we can use. Recirculation and reuse of filtered backwash water. We can appreciate that some of these processes are making a lot of water in their solids disposal. Backwash water is a classic example of that. So let's put that into another settling dam, and then take the water and put that back into the water recycle, and then the sludge, we concentrate that, we take the water out of the sludge. I just want to go back to my slides. Don't panic when you see the number of slides, we'll get to them. So in any water treatment process, you want to consider these. So there we have it. Water return from filter waste, wash water recovery system, and solids dewatering. You're not going to throw that water away. You want to put it back into your process. If you can do that, so any filter waste, wash water, under drainage water, solids to dewatering there. That water we must put back into the process. We're going to reduce that. And that's what you want to do. We want to thicken that up. We want to thicken that up. We want to thicken that up.
And this water is you mainly go in which process? Should we put it in the influent or any process we can put?
Before the coagulation.
Yeah, this one.
So it depends. It's an on-site thing. Why am I saying it depends? this water might have coagulant in it already. So be careful. Garry said we can go and do this. Let's go and do it. And now you do this, you take this water that's got flocculant in it, you squeeze out the water and you take that water with the flocculant and you put it back in here, and you add in flocculant there. Now you might be adding too much flocculant, and therefore your flocculation process is failing. So do it, understand that. Sorry, I'll come to you now so that you can reduce that.
We are adding in the biological tanks, not flocculants.
So that might be chemical enhanced precipitation that you're doing in biology. We'll talk about that later. So we want to do as much of this as possible. Where this goes into where you need to decide on your site, on your operation. You may need to take this to there. There's no pre-sedimentation here, so there might be pre-sedimentation tanks. These ones. Because it's this underflow from there has got flocculant in it, put it into here, it will help settle in there, and then you have a better quality water coming out of here, which means less chemical add there. Or you might want to take that settled water and put it back here, and then, or dewater it and put it back in here, then reduce that as well. Because it will have some in it, etc. etc. It's the same with look at this. Oxidant, disinfectant. What does that mean? We're talking water treatment now. You guys have got me onto water treatment.
Ozonation.
But what is that for? Is that for disinfection? Because look here, there's disinfection as well. Ozonation. We can use ozone there, we can use chlorine there, we can use UV. Why do we have it here? And why do we have it here? Think about it. Give me an answer tomorrow. Because we're not doing water treatment. So we stop, answer that one, we'll go to the next
Aeration?
one. Aeration?
Yeah.
Why? Why do you want to aerate?
In the equalization tank, we are using aeration after
But
screening.
you're getting stuck on your biological process. This is not biological process.
Okay.
But so why on this one?
Chlorine is used for precipitation of iron.
Yes.
In first step, we make it insoluble.
So now I'll tell you tomorrow. Let's carry on. Think about it some more. Okay. So this is just a reference to our legislation. It's not really applicable to you, but what we have done is that we've got a whole lot of different water uses that are registered, etc., etc. What this guideline document looks at is land application. So how can we best start managing that interface when we take sludge to land? And what are the common practices around that? Obviously, we want to take it to agriculture as one of the best options. In most countries, and Pakistan has got big agriculture as well.
Yes.
So what you want to do is support the farmers, or support agriculture with their interface with the soil and crops that they're growing. But we water practitioners, remember, be careful.
Yes.
Because it's someone with the same knowledge we've got with water must have the same knowledge with the soil. So we need soil scientists. And then we need someone who understands the crops. Roses against sugarcane against whatever else we grow behave differently, have different uptake of different nutrients and metals.
Yes.
So you need a plant specialist as well. So these guys, we call them agronomists,
Yes.
should become quite key in our sector when it starts looking at things like this. And so these are very simple little illustrations of what you can do, and you should see what it's reminding us of is the potential pollution that we can generate by our sludge disposal. Because there's still moisture in it. It's not 99.9%.
Yes.
If we had the budget for that, we would have
Yes, of
a
course.
job because they would fire us. But it's not affordable. And it's not necessary, because if you can manage this interface, then why reduce it to 99.9% anyways?
Yes.
So that whole zero liquid discharge. And so you'll see groundwater and surface runoff is two very important aspects that we need to contemplate and understand. We need to look at metal contents. So your metal content in your sludge and your metal content in your sludge can be different.
Must be different.
What is good, what is bad? What is toxic, what isn't? What plants are we using? Metal uptake by plants. Some of them are good for us, some that we eat, we can't have that metal in there, blah, blah, blah. There's a whole document on this. And so the regulator should give you those guidances to say, if you plant in a certain crop, this is the limit in terms of that metal. Yes.
And that limits are available at WRC?
Yes.
Okay.
So I think tomorrow we talk about the sludge guideline documents. I'll give them to you and you can use them as a guideline for metals and crops. Because it's not just about what type of crop, but it's about the application rate as well. So a crop with a certain amount of metal, you can put so many hectares, so many grams or kilograms or tons per hectare for a certain crop, because they would take them up and it wouldn't become too dangerous. It depends on where that metal ends up, if it's in the fruit or if it stays in the root. Some of the plants use it because it's got nutrient in it, so it grows the plant better, etc., etc. It gets complicated.
Yeah.
Is what I'm saying. So bear that in mind though, so get the right expertise. So it's not just for farming, for crops. We can go into forestation, where there's growing of forest to get timber, etc., etc. Same concept applies. The same concept applies for land reclamation, for landfill sites and mine dumps. Ash dumps might need to be clad as your final process. You can take your sludge, if it's the right quality, and cover your dump. In South Africa now it's legislation that no mining operation will get a closure unless they've done this. So they force the mining operation to excavate the topsoil and to go and stockpile that, and then dig their hole in the ground to get to their diamonds or gold or whatever they're after. And the material that they dig out the ground that's waste, they throw one side, then they process the rest that's got the ore in it, and then the material that's now been processed and the ore's been removed is also waste. And those waste piles need to be vegetated before they're going to get closure. And they actually force those companies now to contribute towards a fund, a closure fund. So they would say, oh, and they do the same in our power generation sector. And they should do it in, well, I suppose, textile, they're still too small. Because we're talking big dumps. And very little responsibility at the end of the day, so people have been able to walk away from it. And it's a big problem. So that's for application. If we want to, so note bottom right here. That's what we used to do, right? Or sludge disposal by others. Make it someone else's problem. And that's changed in terms of the responsibility that's required from most regulators, most stakeholders, most people that are influencing the market now. Even it's coming to hotels. Tourists are saying, what are you doing with your waste here at Filetti's? This, okay, and the hotel next door, you're doing that. Okay, we like that, we'll go to that hotel rather. It's fact. And so disposal options need to be addressed. And again, you'll see there's that common under-theme in terms of the pollution potential, groundwater, surface water, The requirement to start putting in lining for that, because it starts getting expensive to put in lining as well. So it starts driving you to start reducing the volume of waste that you want to dispose of. Off-site disposal to a landfill, you now need to categorize it, certain types of waste have certain categorizations, and it's fairly consistent all over the world in terms of these broad categories that you find. This is just a reference to some of it. And so you would be charged according to what you want to dispose. So if your material has got a higher solids content, you'd pay less, etc., etc. So here's an idea. Why don't you just take your water treatment sludge and pump it into your wastewater treatment plant? And yes, you can do that on the basis that these guys know that you're going to do that, and that their system can receive that material. Very often you find that this is a biological treatment process, this is a physical chemical treatment process. You're producing chemical sludge that's inert, and you're putting it into a process that wants organic material, because that's the food for the bacteria, and you just occupy volume in here, so it becomes a big problem. So there's a couple of things that you should consider if you want to contemplate that, but you can do it. And in fact, it can help things like this, removal of phosphorus. So you can do that, and we'll talk a bit tomorrow, because you get phosphorus in sludge. You can do it chemically or you can do it biologically. And some of those chemicals that might be in your water treatment plant or your other treatment plant that comes down the drain when you discharge into a biological treatment process might precipitate your phosphorus out. There should be an agreement in place so that both parties understand what they're doing, and yeah, you can go ahead. Biotoxicity is very important, because you can't kill your bugs.
Yes.
You're trying to grow them in your process, so you don't want to put something in there that's toxic to them and killing them, because you'll never win. Recovery of coagulants. There's work being done on this now. You can start contemplating that. And again, it's horses for courses. Is it affordable for your operation? What is the cost benefit of recovering that material to buying new material? I can tell you that the two are coming closer and closer together, which is going to put pressure on the chemical manufacturers as well, because they probably have had a good margin. So their margin is going to decrease the more that recovery of coagulant market technologies improves and becomes affordable. And so you have a set of obvious benefits associated with that.
Mr. Garry,
Yes.
is there any plant in South Africa that is recovering coagulant like chemical?
Not yet.
We
are still too lazy, and we say, it's too expensive. But they're crying because the big ones, and that one picture that I showed you on linear to circular economy, that big sludge, that's a big water treatment plant for Johannesburg. They're producing millions of tons of settled sludge, and they're just throwing it, or trying to throw it away, and now it's becoming too much. So the areas that have been throwing it away are filled up, so it's becoming viable from a rands and sense or economical point of view. But no, we're not doing it yet. But I think some of the brine that we'll talk about just now will give us some more insight as to what you can start doing with it. We can make bricks. You guys are making bricks. Good. Just remember, you should check to see that there's no toxicity in the sludge, so that when you give the bricks out, they're safe. They don't start glowing at night and things like that. But also that they've got the characteristics to have the strength in the brick making process. Often that's not looked at either. So you have all your strength, your compression strength, and when you bake it, it's got to be a certain strength, etc., etc. So so you mix it normally with cement, and you make bricks.
Yeah.
So normally the cement industry
Adhesive in this.
would have
Also
adhesive. So just make sure that. So from a biological sludge point of view, it's even better because the fibrous content in the sludge helps it to bind. So it makes them really strong, normally. Okay, so yeah, you can burn it, turn it into an additive for cement, dry it out completely. Rehabilitation, yeah.
When we burn it, it's very smelly for the biological sludge.
Activated sludge.
Yeah.
Activated,
sludge.
sorry.
So again, it's a balance. What is our emissions requirement? What is the cost to abate the emission? What is the cost for the incineration? What temperature must we burn it? What is left in the ash?
So much costly
Activated
than.
sludge have many bacteria in it.
Yeah, but if you burn them, they're gone, that's for sure. So the bacteria is not a problem. But it's the metals.
Yeah.
What temperature must you burn to get rid of certain, and what's left in the ash?
So much costly this.
Toxic elements.
Oh, obviously there are a lot of toxic elements in it. Especially for our tannery.
Okay, so that was conventional water treatment, flocculation, coagulation, sedimentation, filtration. Do you want a quick 2-minute, 5-minute leg stretch, fresh air?
Sure.
Sure.
Because I think we're going to target to maybe finish for lunch. What time do you want to finish? 12:31. Let me just check the one. These guys, what time? Because we'll stop for an hour.